Alright, stop having a conversation while your teacher is away from the actual work. Okay, now guys, I've written specifically that we are revising grade 11 presentations because I don't want you to see sine x minus 15 and now think you're going to have to expand that using the compound angle identity. Right, that is a very common mistake in the Trig. Once you learn the compound angle identities, you sometimes just want to use it for everything. But guys, is that going to help us if I actually expand this now to sine x cos 15 minus cos x sine 15? Is that going to help me to solve this equation? Remember, when we have a Trig equation, we're trying to get sine x equal to a number, or cos x equal to a number, or tan x equal to a number. That x, right, the angle can be more complicated, like we have in this case. We have a bracketed angle with x minus 15, or it can be a 2x, it can be an x over 2, all right, the angle can be more complicated, but we want to get sine or cos or tan equal to something else, all right? And we almost have that here, guys. All we need to do is we need to move that 3 over to the other side. So we're going to say sine of x minus 15 degrees is equal to negative 2,181 over 3. I'll work that out now. You can also just leave it like that if you want it actually. What does that give us? Alright, that is negative 0,727. Now guys, I'm going to move this 15 degrees and add it to this number. Okay, it's a part of the angle. I can't move, and I mean, this is not even a value in degrees, so I can't possibly say this plus a 15 degrees. All right, I can't do that. You have your sine, you have your angle equal to a number. You need to find out reference angle. Yeah, that's the next step. So the reference angle is going to be shift sine of positive 0,727. Right, we never include the minus when we are calculating our reference angle. Remember, the reference angle has to be an acute angle always. If we put that minus, we might do something different. Okay, 0,727, and we get that as our reference angle, 46,64. Basically, if I round it off, I'm going to leave it in the calculator, but we can write down a rounded off value. That is the reference angle. But guys, it was saying that it has to be negative. So how do I now bring that minus into the mix? We look at the negative quadrant, right? We need to now work in the quadrant where sine is going to be negative. Sine is negative in quadrants 3 and 4. So we're going to do a quadrant 3 solution. We're going to do a quadrant 4 solution. Okay, that's where that minus comes in. We don't use it for a reference angle, we use it for the quadrants. So, quadrant 3. Now, guys, the angle in this case was a more complicated angle. It wasn't just x. So we can't just say x equals. All right, you have to do the whole angle. I'm just revising, so we have done questions like this before. Okay, so x minus 15, that whole angle we are using. Oh, hello. Sorry, my phone thinks I'm speaking first. All right, so then we are in quadrant 3, that is 180 plus the reference angle. And then plus 360n. N is an element of integers. Do we remember? When we're working with sided chords, we have to say plus 360n. When we're working with tan, we say plus 180. Guys, to get x on its own here, I need to obviously add those two together, and then this minus 15 I'm also going to add. Okay, so I'm going to say x is equal to 180 plus answer plus 15, and we are getting 241,64. Right, 241,64 degrees plus 368. We're remembering the stuff. Okay. Right, so that's the quadrant 3 solution. We still need to do the quadrant 4 solution. Again, x minus 15, that whole angle that we had. Now in quadrant 4, we work with 360 minus the reference angle. So 360 minus 46,64. But again, plus 360n. Now, guys, remember, if you've written in an element of Z1, you're going to write it again. Now, to get x on its own, we need to do the whole, sorry, I'm just getting back to this was my original reference angle. So now we're going to say 360 minus, and then plus 15. And we're getting to that 328,36. Now, guys, if we had just said solve for x, that would be the way we would start. All right. But since they are saying for x, an element of negative 180 to 360, that means that we need to now find the specific solution. Right. So specific. Which means that you are going to substitute whole number values for n into both of these two formulas. What do we start with always? And which n value are we going to start with? 0. Right? Do you guys remember? Because if n is 0, then those are going to be my two values, 241 and 328. Are those in my interval? Yes. All right. So you can say therefore x is equal to, and if we use curvy brackets last year to list them all, I think so, hey? So it was 241,64 degrees and 328,36 degrees. I'm just going to write underneath these two. I'm just going to group them together. This is what we get when n is 0. Just as a reminder of where that actually comes from. So guys, if I make n equal to 1, when we start with 0, then we do 1, negative 1. If I make n equal to 1, do we agree that we're going to get in both of these cases values that are too big for my interval? So it's going to be 241 plus 360. That's obviously bigger than 360. All right? And for this one as well, this plus 360 is also going to give us something that is too big. So n equals 1 is not going to work. What about n equals negative 1? All right, if I make n equal to negative 1 here, I have 241,64 minus 360. It might work, hey, I think, does it? 241,64 minus 360. I'm getting negative 118,36, which does fit into my interval. All right, so I have to list that one as well. negative 118, comma 36. And in the other equation, if I make n equal to negative 1 there, it's again going to be this minus 316. So 328, comma 36 minus 316. And we get, thank you, we get negative 31, comma 64. That also falls into this interval. I mean, that's it. All right, if we minus 360 from those two values again, after that. So these two answers are coming from n equals negative 1. And guys, getting these values is just calculator. All right, but you need to remember you start at 0, then 1, then negative 1. Usually 2 and negative 2 won't work. But sometimes if you have like a sine 4x, right, then remember you have to divide everything by 4. So then that will be a plus 90n. So then you'll get more values from that. Okay, what if we have something like this? Question 2. Cos x equal to sine 40. Not giving you an interval now, so you're just going to do the general solution for this one. But guys, remember sine 40 is a number, right? So you could type that into the calculator, do your shift cos to get your reference angle. But if you have like another x on the side, you couldn't do that. Okay, so when we have a cos and a sine, it's best to actually change whatever is on the right to a cos. Okay, so I have cos x equals sine. Let's change this sine to cos. What is it going to be, guys? Sine 40 is the same as cos 50. It came up in that example that we marked yesterday, right? Co-ratio. This is coming from sine 40 is the same as sine of 90 minus 50, which you can put in as an extra thing if you want. All right, so you rewrite 40 degrees as 90 minus 50. But then when you reduce that, we remember that whenever you have a 90, you need to change the sign to a cos. Guys, this is useful because now I can see my reference angle immediately. I don't still have to go and calculate, right? Cos of x equal to cos of 50. That means that my reference angle is 50. So if you can get sine equal to sine or cos equal to cos, then you can actually just see what the reference angle is straight away. Okay, are we fine with that one, guys? So now for the reference angle, we can just write that straight away. The reference angle is equal to 50 degrees. Now guys, cos 50, is that going to be a positive or negative value? Cos 50, what quadrant is that in? What quadrant is 50 degrees in? 50? The first quadrant, hey, it's an acute angle. It's in the first quadrant. And all of these are positive in the first quadrant, right? Cos 50. So if you type that into the calculator, it will be a positive value. Okay, so which quadrants is cos positive in? 1 and 4. So we're going to have a quadrant 1 solution. Now this one is a nice one because my angle is just x. X equals, I'll be now, let me just write stop. 50 plus 360n. We're going to write in element of this again because we wrote it for the first one already. And for quadrant 4, you're going to say x is 360 minus 50 plus 360n, which you must then just simplify to 310. Yes. Yeah, so you look at what is on the left. So that, because your answer has to be an x value that's going to give you a positive value. And if we were so then you would move that minus across to the other side. And then when you go and work on then you would, because then if you move it across, you're going to get negative sine 40, which is negative cos 50. Then you're looking at negative 7. Yeah. Okay, fine on this one, guys. Yes. And that's thing you were handling. No, not this one. I think we'll do a test on Trig. Or it might just, oh, exactly. We'll see. Okay, I was looking for one more type of example, all right, number 3. Um, 2 sine squared x plus 5 cos x plus 1 is equal to 0. Now guys, we need to look at what we're given, obviously. Sorry, that's very obvious. All right, but we have a sine squared and we have a cos x. I can change sine squared to 1 minus cos squared. I can't change cos x to just a sine. I could change cos x to sine 90 minus x, but then I don't have the same angle, so I wouldn't be able to factorize it. Then we all see that this is going to give us a trinomial, right? Because we have a squared and we have a log squared to the power of 1 and we have a constant term. All right, so you need to be able to look at these 3 terms. And yes, we have some work to do before we can actually factorize it. But this is going to give us a trinomial, or some kind of quadratic equation. All right, so sine squared x, I'm going to change to 1 minus cos squared x. So that I have a cos squared because I have a cos x there. Okay, if I had a sine x, I wouldn't be changing the sine squared x. Then I could factorize right from the start. Okay, so my sine squared x, I need to change to 1 minus cos squared x. Then plus 5 cos x plus 1 equals 0. Then I'm going to multiply the 2 into the bracket. So 2 minus 2 cos squared x plus 5 cos x plus 1 equals 0. Now I'm just going to add like terms, right? 2 and 1. And I'm going to write it in the correct order. So I have a negative 2 cos squared x. And I have a plus 5 cos x. And then my like terms, 2 plus 1 is 3. And that is equal to 0. Now what can I do? Write through by a negative. Okay, you don't actually have to do that because I'm guessing that we're going to use the quadratic formula. We're making the right assumption here. Or do you guys want to factorize that? You can factorize it if you want, but I think most of you won't want to. That's fine, you don't have to. We can use the quadratic formula for this, right? It is a quadratic equation. But guys, am I going to write x equals the whole thing? No, what am I solving for here? Cos x. All right. Negative b, my b value is negative 5. All right, so negative 5 plus or minus the square root of b squared, so negative 5 in bracket squared, minus 4 times a, which is 2, times c, which is negative 3. That is then all over 2a, which is 2 times 2. You're going to type that in with the plus. You're going to get one answer. You're then going to move with using the arrow button. After the plus, delete it, change it to a minus, and you will get 2 answers. Cos x is going to be equal to negative a half. Is that one that you're getting? Oh, sorry. Is it 3 first? Okay, so 3, and then the other one is negative a half. Now that gives us 2 just straightforward Trig equations where you have cos x equal to a number. And that can cos x ever be equal to 3? Because then you have the graph of y equals cos x. It goes from 0 to 1, then back down to 0, -1. It never reaches 3. So guys, if you type in shift cos of 3, it's going to say math error. Okay, and that is why, because the cos graph will never actually go up to 3. So at no point, at no x value, will you ever have cos of that value equal to 3. All right, so here you're just going to get no solution. For the other one, reference angle equals. Now, some of you might know what this is. Which angle is going to give us a half? Cos of which angle will give us a half? It's 60, hey, isn't it? Cos of 60 is a half. Sine 30 is a half. Cos 60 is a half. Okay, but you can use a calculator for that. That's fine. So for the reference angle, we use positive a half to get that acute angle, but because it's negative a half, we have to work in quadrants 2 and 3, which is where cos is negative. So my quadrant 2 solution is going to be x equals, because the angle is just x, right? So first x equals 180 minus 60 plus 360n, which is 120 degrees. And guys, you actually don't have to write down your, like this 180 minus 66. You can actually just do it on the calculator. Okay, they only actually give a mark for the 120. But when we're doing examples, it is good to write the working down so you remember where that 120 came from. So that's the quadrant 2 solution. Quadrant 3 is 180 plus the reference angle, which is 240. And usually that will be the case, right? When it's a trinomial, so if you're getting two values for cos x or sin x or whatever, usually one of them will be too big or too small. So if this was like a -2, for example, you also would get no solution. So there's usually no solution one and then one you have to calculate. Okay, I'm going to give you some of these to practice before we on Tuesday move on to the ones where we're actually using the new identity. So guys, for these ones that I'm giving you now, I don't want you to use the compound angle identities or the double angle identities. They are all grade 11 type equations. All right, it might seem like you need to use compound angle identities. I'll show you an example now. But please don't, I'm going to make it very difficult to solve. Okay. I just want to show you these. Hey guys, that is 1B. Now, what I meant earlier when I said please don't use the compound angle identities, it looks like, I mean, you can expand it, right? We know a compound angle identity that will allow us to expand it, but do I need to? That's the question. No, right? I don't want separate terms equal to a cos 70. That's not going to help me at all. That's going to make it very complicated. So if you expanded this, don't write this down. I just want to show you what will happen. You'll get sin x cos 20 plus cos x sin 20 equal to cos 70. I'll tell you how many people do that. All right. And then you start. What can you do now? Right, you're supposed to have a sine or a cos or a tan of an angle equal to something else. All right, you're not supposed to have so many terms. So what could happen, guys, you see on Tuesday, they can give you this. That might be the question. All right, they might give you the expansion of the compound angle identity, and you then need to put it together as the bracket instead. But you will never have to go from a sine or cos, well, we don't have a time, so a sine or cos of a bracket and expand it. Okay. You won't get any marks. Lots of people do that and then they get 0 going forward because they can't do anything. Okay, so please do not do that. What am I going to change this cos 70 to? Sine of 20. Right? So that my reference angle is 20 degrees. Okay, keep going, guys. This is for Tuesday. It